Hi, welcome to the GF channel. Today's episode I'll finally make this work. Of course I'm going to reprint this model with black. It's white because it was the first model that I 3D printed and I used the color that came with the printer. So I'll redo that. Model is in the description. It's not made by me, but it fits perfectly. So why do I want those? Well, first there's the Mazda MPS, Mazda 626 or Capella. It's actually a Capella, but it's the first MPS introduced in Geneva Show 2000. It looks awesome, and one of the things it has, this is at the back. This is the engine, KL. It's 280 horsepower, twin turbo. But here, let me zoom in a bit. Here you can see these. I like those. So I decided I'm going to make myself an MPS-like clocks. And because I do not have a twin turbo, I need to measure stuff that are more relevant to my car. That's why I decided to measure the oil pressure, oil temperature. I haven't tightened these, and the voltage, charging voltage. For these, I actually plan to use this. Now that's an issue. This is Chinese. I'm not going to even place a link in the description because lots of problems. All of the sizes, all of the thread sizes are not good. So diameter is good, but for instance this bolt here for the third hole came with the kit and it cannot fit the thread size. Thread size is different, diameter is good, thread size different. So you can see there is some thread still out, but I cannot tighten it more. Same goes with these. These are separate. These did not came in the kit. I actually ordered them separately. They cannot thread in good. They just stop threading in. So I'm going to use some Teflon tape. It should hold, hopefully. We'll see if the oil starts leaking. I'm currently here to change my oil, so it's a good moment to start testing that. Another problem with this one that I had is the adapter it came with. Now this adapter is custom made. I went to a guy and he made it to me. But there were two adapters that came with this one. One was supposed to be 1.5 M20 1.5 or something like that, which is exactly the same as Mazda filters, but it wasn't. It was not tightening to the filter. Again, thread size different. So Chinese don't have any idea of threads, any idea. Everything I did try to thread did not work. This is made custom, which fits good, but this not. And the final problem I have is with the filter. Now, this is the filter I usually use with the car, and the problem with that filter is the O-ring here. If you place it like that, it's the way it's supposed to go. Let me try to actually show you somehow. If you place it like that, you are going to see the oil ring actually sticking out. Half of it sticks out. No matter how good you align it, it always sticks out. So this is a little bit narrower than it needs to be. And that's why I'm going to change the filter. And it's even cheaper filter. But the thread is the same and it's a little bit wider as a diameter. So this will now fit properly here. Nothing sticks out, much better. Okay. The installation is simple. You place this, we'll see how it's simple because this sticks out a lot, as you can see. I'm hoping there is a cavity somewhere where this can fit without an adapter. Otherwise I'll have to make an adapter for this one. But simply you stick this one onto the engine block, use the adapter like that, just thread it in, tighten it, and then here your oil filter should go. That's that done. This as an electrical connections, everything grabs ground from, well, the engine, and you have two exits, two outputs. I don't remember which one was alarm and which one was analog. So one of them is meant if there's no oil pressure to give you an alarm, just like the stock sensor does. But I'm not going to actually remove the stock sensor. I'm still going to reuse the stock sensor. The benefit is, well, everything is stock, while the downside is I'm going to have to pull another wire. Instead of reusing the wire from the stock sensor, I'm now going to have to pull another wire. The other one here, one of the two, the other one is an analog, which supposedly, if Chinese are correct, should work with this gouge here. This one, since it's a pressure, you can actually make a kind of a U-turn, or not U-turn, L-shaped adapter if it's in the way, and it will work. This one, this is for the temperature. Now this one, it's good to have oil flowing through it, so the temperature is actually correct. If you make an adapter to it, oil will not flow. It will fill up once and it will not flow, and the temperature won't be accurate. But fortunately this is not in the way, so that should not be a problem. Only this might be a problem. And there you go. Here it says the sizing. What does it say? M10 plus 1. M10 plus 1. And I bought these for M10 plus 1 as well, but they're not. Okay, so I drain the oil, and I check if I can mount this or not. We'll see when the oil has been drained. Okay, let me try to squeeze in. This is the placement. There is enough room, no adapters will be required, and I believe I'll be able to wire in the cables afterwards. Okay, engine seems to be running, and I do not see any leaks. Everything seems fine, which is good. Okay, some testing. Okay, no lamps flashing, so we have not lost the fuel pressure. Very good. I'm happy. Okay, wiring time. Now we're going to have issues, especially with the backlight. It's quite simple. It looks quite simple, but it's not. You have a ground, you have power, and you have backlit. And these blue ones are the additional signals for the corresponding sensors. Now, this one that does not have, it measures voltage. And you already have the voltage. It's being carried by this line. We need to connect this to ground, and we need to connect this to, we need to find first the ignition line that does not disconnect while cranking. There are two ignition lines. One ignition line actually disconnects everything while cranking, while the other one does not. I would like this one to actually show the voltage while cranking. This is a good thing to do. So work is needed here, but that's not a problem. Even if this one had such a wire to have a different supply for measurement, it's not going to work, because this one is going to disconnect and it will power off the unit, and even if you have additional 12 volts here, it's not going to measure. So this setup is good, we just need to find the proper wire. This is solvable problem. Now the backlight, I believe we are going to get stuck there. The problem with the backlight is the way it works. Now I'm actually going to demonstrate you. We are going to connect the ground. Okay, don't run please. Connect the ground. And now if I just get this one, let me turn it around and actually make sure I am connecting the proper wires. And now if I just place the backlight to the 12 volts, you see this does not get lit. But why? Well, apparently you also need power. So you need this one to be powered on somehow. I'll have to actually tackle it in. With one hand, extremely hard. Come on. Oh, okay. So I have it here, and now you can actually see it blinking because it does not have pressure. And now if I connect this, then I have backlit, which is terrible. The backlit of the car does not work like that. You can get the backlit to all of the components without having turned the key to ignition or even to ACC, which kind of sucks. So this is going to be different. And to be more problematic, the backlit is adjustable, and it's adjustable by PWM, which means I will have issues dealing with the PWM. My best guess is I'm going to have to run without backlight for these, unfortunately, or find different ones. We'll see. After I check everything, I'll show you in the car when I'm checking. After I check everything, I'll have to do some cable management, and my idea is to actually connect all colors of the same, all wires with the same cover to a single line, and actually use this connector so I can quickly disconnect all of the three. Otherwise you need to remove the rubber here, and there is a connector in, but that's hard to reach. It's much easier if I have external one. Just remove it and remove the whole panel, and it's also going to make those long cables disappear. And I'll have to check for power consumption, because these grounds are quite tiny, and the way I'm going to arrange those into the connector might be of an issue if it's too tiny, because the ground needs to carry not only the power consumption of the unit, but also the backlight. We're going to measure it again. Let's first see, will we use the backlight or not? So let's debug the backlight. Now the backlight, always in the car, are those two wires, the white with red and the light green or blue cyanish thingy, this one with the black strip. This is always the backlight in the car. So I have picked up the two wires, and let's see what happens. Let's turn off the torch. Let's turn on the backlight, and we directly get 12 volts. Now when I start turning this knob here, you can see it gets lowered and lowered until it reaches 3.2 volts, all the way from 12.4. Good. And now you think, maybe if I grab the ground and I shove it to car's ground here on this beautifully looking cigarette lighter with this beautiful background, backlight, which I have another video for that one. can click the thingy at the top. And now I grab the ground from here, and here we have it. I have ground and I have 12 volts. But if I turn this knob here, which I have a video for that one, how I make it shiny, I start turning it and you can see the backlight actually dimming, but the voltage is not dropping. It's not changing at all, which is bad. This means I will be able to use the backlight here, as I'm going to show you now, but I'm not going to be able to actually adjust it. So now what I'm going to do is remove this and grab the prepared thing here, shove it in, and with that I have this one running. And now we grab the yellow, which is the backlight, and we just touch this wire with the red pin here, and you can see the backlight is here. But if I turn the backlight all the way down, you're going to see this is still bright. So if I'm able to shove it in, yes, I have shoved it in. Now I can actually use the knob as well. I turn, it turns, but this one is not adjusting. So the choice is without any backlight or with always full brightness on backlight. I'm going to choose the second one because it's better to have backlight than not. Now this is an old one, as you can see, broken. It's with a black clock, not white one like these, and I already broke it, but it serves the purpose here. So now let's go and measure how much will it draw all the three with the backlight and without the backlight. Okay, power consumption time. It draws about 700 milliwatts while no backlight. And if we add the backlight, here we have it, that's the backlight, and about 1.5 watts, 100 milliamps. That's nothing. Even if it doubles, 200 milliamps, those cables will be able to handle it. Well, it's interesting to see, maybe without the backlight on the camera, it's not visible well, but live it's much better. I don't know why this one has stronger backlight than the rest. I don't know why, but that's the case. So let's see, it's a little bit over 14 volts because I'm a little bit over 14 volts. Let's start dropping and see how it drops here. So it dropped to 12 and now it's a little bit 13. So it needs time, it's not instant. I drop and now it drops, like 2 seconds. I up and now it's up. So it needs time, like 2 seconds. Let's count. 0, 1, 2, second and a half to 2 seconds maybe. Okay, and it's 10 volts, apparently it blinks. Okay. Now let's use this connector to make the cable management better and then start finding the signals in the car. Okay, cable management here is done. I think it looks nice and it's time to test if it's working. Okay, now grab the backlight and touch it here. Okay, we have the backlight. Good. So let's proceed to find the signals in the car. So, signals within the car. I'm talking about the signals coming from the car itself, the power, the backlight and the ground, not the signals from the newly installed sensors. We're going to cover them after that. Now, there are a few connectors here that can help all of them grab the 3 signals. Each have its own advantages and disadvantages. Only this one should have them all. This one should have ignition somewhere because it acts on ignition. So some of these wires you have to trace them, but I don't want these. I never tapped into them, while the other ones will do. So this I'm not going to use now. But this is for the climate control. It works on ignition. It has a backlit and it needs ground. So it has all the required signals right here. Probably the black is the ground. Ignition should be black with yellow stripe, or actually yellow with black stripe. No, black with yellow stripe. And the cyan with red with black should be the needed wire for backlight. This one has all of them. You can see I have tapped into it multiple times, and not only that, I actually added most of the cables here. And these are added by me. I have another video for that one, installing touring computer on a 1.8 liter, which never had touring computer. So I added most of those wires. If you have a touring computer or you have a connector which has so many wires, you're in luck. All of the wires required are, or all of the signals required are here. So you grab the ignition wire, which is this black with yellow. That's the ignition. That here next to it, probably black cable, is for ground. And there's the cyanish cable here, which should be the, or maybe on the other side. Yes, this one is for the ground, for the cyan with black. This should be for the backlit. Of course, retest everything. I'm going to use those. If you don't have ignition here, in this connector you always have it. But if you don't have a touring computer, you won't have probably ignition because it's not needed for the clock. What it's needed for the clock though is backlit and ground. So you have backlit and ground here. And ignition you can grab from this connector, which is from here. It's the same wire which I have already spliced into it. This one, black with yellow stripe. This is the wire you need to tap into the ignition. Now this ignition is not what initially I wanted to use. This is a switched ignition, meaning while cranking the engine, this turns off. There is ignition line that does not turn off while cranking. I wanted to use that one so this can actually show me the voltage drop. But this is so slow that most likely engine is going to start running until that updates, and that does not justify the risk of burning the fuse, which is for the other ignition, which actually provides power to the starter. I don't want to burn that fuse because I'm going to not be able to start the engine. I prefer to use the other ignition line that is switched off while cranking. It's better. Okay, I'll now tap into those, and I'm going to show you how it looks like with these actually connected to car signals. And if there was a change in the plan, I'm going to show you as well. So, only the 2 signals from the engine bay are left. The other 3 signals I got from the connector of the power of the touring computer. And there seems to be plenty of space behind this, which is good, even with my amplifier here taking up space. So let's see now. If I turn on the backlit, so backlit is on, maybe I'll turn off the torch so it's more clearly visible. So backlit is on. This is not on because I need to also turn the ignition to on. And you can actually see this going up way slower. Okay, I'll need to 3D print this in black, as I said previously, because everything is red. It glows red, which I don't like. Okay, now let's start the car and see if this is going to drop while doing so. Yep, it did drop expectedly. Okay. Whoa. I don't know why on camera it's so crappy. When looking at it live, it's much clearer. Okay, almost 15. That generator is over generating. Good. Now let's do these cables. For that I have already a video how to actually get those through the firewall there. There's a firewall there. When I'm actually installing the cruise control from A626. But since I installed cruise control from Mazda 6, I actually put another cable set for the Mazda 6, and I have cables from the 626 for the lever here, and I'm going to reuse those. I'm going to reuse 2 of those cables, which should be somewhere here. I'm going to explain in a bit. Okay, wiring time. Now right here you can see in the background is the sensor for the oil pressure. I thought I could reach it from here, so I removed a lot of things, but as you can see, no, I cannot. Let me turn on the torch. So at least I can do the cabling from here. So you see this cable right here, it actually goes like that at the back of the engine, and there is a tiny cable that comes out of it for the oil pressure gauge. So I'm going to use the same idea and pull the cable through here to the two new sensors, and the cables I'm going to use are these. Now these are 4 cables here, I need only 2, and this is for the actuator, the Mazda 626 GF cruise control, which used to be here, but then I did this Mazda 6 cruise control and I put new wires for this one, so I have spares left. I'm going to use exactly 2 of those, and I'm going to actually cut the tie there, move it to this, come on, move it to here, and then go straight there. I believe I should have enough cable. Worst case scenario, I need to add a little bit more, we'll see. And since I thought I'm going to be able to reach from here, it's hard. Maybe it's possible, maybe, but just in case, I have picked up the whole car and I'm going to do it from beneath. It seems it's hard from there as well. It's best if it's on a hoist and it's high in the air, but it's going to work nonetheless. So first things first, I need to prepare the cable, pull it to there and see if the everything fits, and finally wrap it. Let's go. And these are the cables which are going to go towards the engine. So as I said, I'm going to place them from here, and they are quite long. I'll probably even have to tape them somewhere here so they're not wobbling beneath the engine. So these are both cramped, so I did cramp them and I also soldered them, and then I used additional heat shrink on top to strengthen here. My fear is when I'm actually doing something on the engine, I'll pull the cable here and it's going to pop. So that's why I added solder as an additional precaution. I know solder can, it's not good on vibrations and temperature, but it's additional precaution, as well as this heat shrink to make the thing more sturdy, so it does not actually cut here with the time. So I'm going to place those now. There, I've removed already from beneath. It's not easy, but it's doable from beneath. I've removed the nuts. I'm going to place it and then close up everything here and go inside of the car where the other side of these is. Now, of course, if you want to know how I managed to get those through the firewall right there where the whole loom is, you have to watch the video where I installed the cruise control from 6 to 6, not this 6 version, the 6 to 6. There I show how I actually pull cables through the firewall and they look stock. Let's continue. Okay, car is up and running. It's already at 84 degrees coolant. I have the cables here, prototyping. Come on, focus. The two cables are coming to here, but as you can see, there are two problems with both of them. This one is not showing at all, which is a problem, while this one seems to be showing too much, probably double. You can see it's almost 2000 and I'm idling 2 bar, and I'm idling. I believe it should be more less. I will give it a little bit of gas. Okay. Let's see. I'm at 2000, 2.5. That's actually the maximum. I'm already at 3000. It doesn't move. So probably at 2.5 it just about, yeah, below 3000 to 2700, and it maxes out at 2700. That's not good. That's definitely not good. And this one is not moving at all, and it should be moving. The coolant is 85 degrees and this is not going anywhere. So what I'm planning to do is to test this broken one to see if it actually shows better than this one, to try to figure out what I should buy next. Should I buy another one of these or another sensor? Same goes for this one. This is a temperature sensor. I'm going to actually use this one with a heat gun. There's the heat gun there. Heat it up, connect it to here, heat it up, and it's a brand new sensor. So I'll figure out, should I change this one or the sensor. Let's do the debugging. Okay, a few months later I decided to actually buy new ones, so I waited for those to arrive. Also, these came with their own sender units, so I had to wait also for oil change because I needed to swap the ones that I already installed. These work marginally better. They still do have 4 problems, 2 of which I'm going to have to get used to, and 2 of which we are going to solve. One important thing I actually forgot to mention last time is the way we mount all of those. You need to actually grind the caps at the back. I had to do that for the white ones, and the same goes for these. As you can see, I have grinded because it sticks out too much and you cannot twist the cap, and it actually even hits here and at the bottom as well. So what are the problems with these? Well, problem number 1 is, as you already can see, they just stop at random positions. So they have this cool animation, and now when I turn it off, it drops to somewhere and it stays there. Now if those were up high somewhere, they would also stop somewhere. Let me try to show you. I can stop it in this position, for an instance. So it's at random position every time, which is not quite good looking, but okay, it's fine. The other problem is the backlit actually changes the sorry, I'll do this so it doesn't beep. So the other that you just have to get used to it. Come on, focus. Look at the voltage. Now if I turn on the backlit, voltage drops. Turn it off, it goes up again. Turn it on, it drops, which it's not good. And it's not because I get a load to the car. I noticed the same on the bench. The proper voltage is actually when the backlit is on. This one is not proper. Now to the fixing part. You hear that clicking? That's the flashing relay. It just clicks when those are installed, because those are too noisy. That is problem number one we are going to fix. It just needs, I discovered, a little capacitor. I'm going to show in a bit. The other problem is backlit is extremely bright. That's way too bright. We need to add a resistor to lower it, because the backlit here has the same problem with these. You cannot adjust it. So I'll have to fix it with a resistor. I found that 1.5 kilo ohm resistor works okay. Okay, let me now disassemble and show you how to fix the problems. And here are the fixes for the problems. First we cut the line which is for the backlit and place a resistor so the current goes through it to lower the brightness. On the other side we have the capacitor. This is 10 microfarad at 25 volts, I think it was. 10 microfarads, yeah, 25 volts if it focuses. So this one should be between the power lines of the all the clocks, between the power lines. So ground goes to minus of the capacitor and the other leg goes to the plus side, which is basically ignition. Okay, I will now isolate everything here and show you how it looks like. And here we have it. The fix is there. By the way, these are the old connectors for the old system, just in case I decide to change these and they come with this type of connectors. I have left them. Let me turn off the torch. Okay, now place it here. As you can see, I'm already on ignition. No clicks, nothing. Very good. And now the backlit, much closer to the one down. Now the camera doesn't represent the thing properly, but it's way better. Okay, let's go outside, show you the final result. Okay, sorry it's a bit shaky, but these work magnificent. I'm happy. So currently I'm going downhill. This is at idle. I'm very happy. Yep. Quite good. And this one also shows